Now what we're going to be doing is looking to actually draw out the graph for this equation or function. Okay, so we're going to end up always having something that's a parabola, right? So it might be this way, it might be that way. Okay, and what you'll also find is obviously we'll be drawing it against an axis. You'll find if it cuts across the x axis, obviously y always equals 0. Okay, so these are known as the roots, and if it cuts across the y-axis, x is always equal to 0. Okay, so these are a few rules, and you'll probably also find that the very bottom of the curve, or the top of the curve, that's known as your turning point, and your turning point is where it's perfectly symmetrical. Okay, and it's actually the x coordinate, your turning point, is right bang on in between the two roots. But that's essentially what we'll be doing. Okay, so we're going to be calculating the y-intercept, sorry, x and y, and stating the coordinates of the turning point, and then drawing it. Okay, so if I get rid of all that, we can then start. Right, so first thing we'll do is find the x coordinates. Okay, so these x coordinates are known as the roots. Now, all these equations take the form of x minus m, x minus n, and what you'll actually find is the value of m and the value of n, these are actually where it crosses the x-axis, so that's known as the roots. But these are actually worked out because the roots are, are when y equals 0. So if we actually just draw this out, our 0 equals x plus 2, x minus 4. Now there's two roots here, okay, two values of x. So what we actually need to work out, what value does x take in order for this side to equal 0. So we can take them independently. So if we take this part of the equation, we are wanting this part of the equation to equal 0. So 0 times what's in this brackets will always be 0. So if we have x plus 2 equals 0, I'll take away 2 from each side, so x equals minus 2. Okay, now this is where it crosses the x-axis, so that is when y is 0, so your first root is at minus 2, 0. Okay, so again, to find the roots, or find where it crosses the x-axis, make y 0, and then we have to look at inside the brackets and making each of these brackets equal to 0. So this equation is balanced. So if we then look at the second root, so we have x minus 4, x minus 4 equals 0. I'll scroll this up a wee bit. So x, what could x be in order to have that side 0? So we add 4 to both sides to isolate the x, so x equals 4. So that's your second root. So what we've got is a root at position 4, 0. So we can then, hopefully this works out, if I start sketching this out, we've got one root at, I'll just say that's roughly minus 2, and we've got another root at, say that's 4. Okay, so that's 4, 0, and that's minus 2, 0. So that's us got the x-intercepts. Now, the y-intercepts, to do that, what we're having to do, and I'll choose a different colour, what we're having to do is work out when x is 0. Okay, so when x is 0, so remember this is your x, this is your y, so when x is 0, that's when it's crossing this y-intercept. So all we do here, okay, so that's your x-intercepts. So to calculate your y-intercept, so just say y-intercept when x is 0. So we just say y equals 0 plus 2, z 0 minus 4. Okay, so we're just setting x to be 0. So that gives you y equals 2, in this bracket times minus 4. So y-intercepts the y-axis at minus 8. So what we're going to have to do here is I'll just extend this down a wee bit. Again, this isn't to scale, but it'll be as good as, right? So this intercepts round about minus 8, or 0, minus 8. So we're going to have a parabola that turns roughly like this. Now I'll try and sketch this out. We have to give it a couple of attempts. Third time lucky. Right, so we know the x-intercepts and we know the y. All we need to work out now is the turning point. Okay, and hopefully I've given myself enough room. So the turning point is here. Now what you'll find, sometimes ask you for the equation of the line of symmetry. Now these graphs are all symmetrical at the turning point. So what we can work out is the x-coordinate of this turning point, because the x-coordinate of the turning point is basically, you add these roots, it's the average of where the roots are. So if I say turning point, if I go, I'll just say R1 plus R2 and divide that by 2. Okay, so that is minus 2 plus 4 over 2, so that gives you 2 over 2, which is 1. Okay, so this is where it's symmetrical at x equals 1. So we now know this turning point is at 1, but we don't know the y value. And to work out the y value, all you actually do is you put in the x value into this equation and you'll work out what y is. So we know the equation is y equals x plus 2, x minus 4. We know that the x coordinate is a 1, so we go y equals 1 plus 2, 1 minus 4, which equals 3, and that's minus 3, which equals minus 9. So that's a y coordinate which is at minus 9. And it looks quite realistic. So, and that's how you answer these questions. Okay, so just to recap, it's normally 3 things you have to work out. Okay, so you have to work out where it crosses the x-axis, and that's when y equals 0, and where it crosses the y-axis is at x equals 0. Okay, where it crosses the x-axis, that's known as the roots. Okay, so that's root 1 and root 2. So again, you would just make y equals 0 and then work out for each of these brackets. These are each separate root. Okay, so that's your root 1, that's your root 2. You then work out where it crosses a y-intercept is when x is 0. So again, you just rewrite the equation, but with x being 0, and it works out where it crosses a y-intercept. You can then work out the x-coordinate of your turning point just by taking the average of the 2 roots, and then you take that value and you place it into the equation, and then you can work out the y coordinate of the turning point. Okay, so that's your turning point. There is a fair amount of work in it, but once you practice it, you'll actually see it's not too bad. But that hopefully has helped you.